Welcome back to Math 103. This is video number 8 on measuring power. We continue with the same example of a parliament set up as a weighted voting system with quota 12 and weights 7, 5, 3, and 2. The background here is that there are 4 political parties, and they received 7 million, 5 million, 3 million, and 2 million votes, respectively, hence the weights. For each party, compute the percentage of the popular vote that it received in the election. In other words, its percentage of total weight. Well, the total weight here is 17. The total number of votes is 17 million. Right, so A received 7/17ths of the popular vote. Okay, its weight in this weighted voting system is 7/17ths of the total weight. So A received 41%, a little over 41%, of the popular vote. Now, you might have thought, by setting up this proportional voting system, many people think that by setting up this proportional voting system, what you're achieving is giving Party A 41% of the actual power. Similarly, Party B receives 5 out of 17, 5/17ths of the popular vote, and is given 5/17ths of the total weight, so it has received 29.41% of the popular vote, and you might think that by giving it weight 5 in this system, you are making sure that Party B has 29.41% of the actual power. Similarly, Party C receives 3 million out of 17 million, that's 17.65% of the total popular vote. D receives 2 million out of 17 million, that's 11.76% of the popular vote. Now when we compare each party's share of the actual power, that's what's measured by the Banzhaf power index, to its share of the popular vote, which was set up to be the same thing as the percentage of total weight, we can ask, is any party shortchanged? Well, A gets 50% of the power, even though it received only 41-something% of the votes, and B receives 30% of the actual power, quite close, in fact, to its percentage of the popular vote, of the total weight. C, however, receives only 10% of the actual power, in spite of receiving 17.65% of the votes. That is, in proportional terms, a rather substantial difference, and you can see where Party C might be calling up their lawyers and looking to file a lawsuit. Party D was slightly shortchanged. It's in this kind of setting, measuring how badly shortchanged one party is, or how badly shortchanged some district or region is in a proportional voting system, that Banzhaf got his start and became quite distinguished, bringing lawsuits challenging the constitutionality of such arrangements. Now we come to a new type of problem, which some students find difficult at first, but it's actually not so bad once you get used to it and realize that the thought process is really, underneath it all, the same as what we've been doing all along. Here's the setup. We're given a complete list. A complete list. The fact that it's complete is very important. We're given a complete list of all the winning coalitions in a weighted voting system. We're given no information, though, about numerical quota and weights. So it's possible, just with this complete list of winning coalitions, it's possible to determine which players are critical in each winning coalition. And once you know which players are critical in each winning coalition, you can also find the Banzhaf power distribution. As an example, consider a weighted voting system with 4 players, let's call them A, B, C, and D, whose complete list of winning coalitions is as follows. So here are all the winning coalitions. So here's our task. Find the Banzhaf power distribution. So find what fraction of the actual power each player has here. That might seem intimidating at first. And determine if there are any dictators, veto power players, or dummies. So now we get to find out if we've really understood what critical in a winning coalition really means. We ask first, is A critical in the grand coalition? Well, if we cover up A and look at the remaining players, B, C, and D, we ask, are B, C, and D themselves a winning coalition somewhere else on the list? And no, they are not. It follows that A is critical. they need A to continue voting yes in order for B, C, and for this coalition to remain a winning coalition. This would cease to be a winning coalition if A departed, because BCD is not a winning coalition. We could reason that out without any reference to numerical quota and weights. All the information resides in knowing the winning coalitions and being sure that that list is a complete list of winning coalitions. Okay. By the same token, B is critical in the grand coalition here, because if we covered up B and looked at who's remaining, so A, C, and D are left if B drops out, ACD is not somewhere else on this list. ACD is not a winning coalition. Therefore, B is critical in the grand coalition. They need B to stay there and to continue voting yes in order to remain a winning coalition here. How about C in the grand coalition? If we cover up C and look at what's left, ABD is left. But ABD is indeed another winning coalition somewhere else on the list. So C's departure from the grand coalition is not disrupting anything. It is not turning a winning coalition into a losing one. So C is not critical here. And by the same reasoning, D is not critical here either, because ABC is indeed a winning coalition somewhere else on the list. Great. That settles who is or is not critical in the grand coalition. And we continue by the same thought process. We look at the coalition ABC. We see that if A departs, then that leaves just B and C, who are not able to win on their own. So A is critical here. By the same reasoning, B is critical. And C, this is important, if C quits, that leaves A and B, but A and B together, just the two of them, do appear elsewhere on the list as a winning coalition. So C is not critical here. In the next winning coalition, it's the same story. A and B are each critical, but D is not. Okay? A and B by themselves don't need D to stick around and continue voting yes in order to pass something, so D is not critical to them. And finally, when A and B are together, just the two of them, they are both critical. Okay. Neither one can pass a resolution, can pass a proposal single-handedly. Therefore, when you have only two players here, each one is critical. Great. What does that give us? It gives us a total of 8 instances of criticality, of which A controls 4, which is to say that A has 4/8 of the power, which is half the power, or 50%. B similarly possesses 4 of those 8 opportunities to exercise real power, according to Banzhaf. Okay. So B also has half the power, or 50%. And now C has no instance of being critical, so C has 0 out of 8, which is to say 0% of the actual power, and similarly D has 0% of the actual power. Okay? So right there, we can read off the dumminess of C and D. So let's just go through and answer this question as it was written, determine if there are any dictators, veto power players, or dummies. Well, we just figured out that C and D are dummies because they are never underlined, they are never critical. So it follows that C and D are dummies. How about dictators? Well, there is no one person, one member winning coalition, so there is no dictator. Okay. And finally, veto power players. Well, to be a veto power player can be detected in several ways. One is to be critical in the grand coalition. So A is critical in the grand coalition, therefore A has veto power. B is also critical in the grand coalition, so B also has veto power. We could also have noted that A appears in every winning coalition, and B also appears in every winning coalition. So it follows that A and B both have veto power. And we figured all that out without numerical quota and weights. Before going on to the next video, Consider a weighted voting system with the following complete list of winning coalitions, and answer the questions below. So here are the winning coalitions, and the questions are: find the Banzhaf power distribution, determine if there are any dictators, veto power players, or dummies. So these two are just like what we did in the previous couple of slides. And finally, compute how many times more power A has than D. How much more real power A has than D, according to Banzhaf. That's a slightly new question, but think about how you would answer it.